Hi guys, and this video we will be discussing about that as how to find the sum of a geometric progress. And if you want to know more about the geometric progress, like what is the first term, the last term, and the nth term, how to find out that value and all, then you can look into that previous video. And we will be in our channel we will be dealing most about that maths problems and physics problems as well. So keep watching and please do like and subscribe. So how your geometric progress will be looking like? The first term is a, and the second term is ar. The third term is ar square, and the last term is a into r power n. So this is how your geometric progress will be looking like. So the ratio between the first term and the second term, that is r, that will be same. So if you take the ratio between term 3 and term 2, that will be same. This is how a geometric progress will be looking like. And to find the sum of that series, if we know that the number of terms are finite, the value of the n is defined, then we can use the sum of the series S1 is equal to a into r power n minus 1 divided by r minus 1. And if the sum of the number of the terms are infinite, so in that case we can use the formula as a by 1 minus r. So in this case we don't know what is the nth term, or there is no nth term. The series is keep on going actually. So let us have the first problem. The first problem is, let us find the sum of the first n terms of a geometric progress. 5 comma minus 3, 9 by 5, minus 27 by 25. This is the first series. So formula for the sum of the series is a into r power n minus 1 divided by r minus 1. And here the first term of the series a, that is equal to 5. And the ratio, common ratio, that is equal to t2 by t1. So t2 by t1 is equal to second term is minus 3 divided by first series 5. First term 5. So the common ratio is equal to minus 3 by 5. Then we can apply the formula for the s of n. S of n is equal to a into r power n minus 1 divided by r minus 1. So a value is 5. A value is 5. And the ratio is minus 3 by 5. The whole power n minus 1 divided by the ratio value, that is r minus 1. Again we can apply that. So finally in this sum, since in this sum we don't know the value of the n, we will be just applying the n, that letter only. So if you know it is the first 6 terms or first term 12 terms, then we can apply that value of the n. But in this case we don't know the value of the n, so we are directly simply applying the n. And finally we will be getting the value as 25 by 8 minus 25 by 8 into minus 3 by 5, the whole power n minus 1. Second sum, find the sum of the first 6 terms of a geometric progress. So first they gave the first 3 terms of this geometric progress, and we need to find out the sum of the first 6 terms. So the given a, that is the first term, that is equal to 5, and the ratio, that is t2 by t1, that is equal to 15 by 3, and we need to find the sum of the first 6 terms. So n equal to 6. And formula for the sum of the series S of n is equal to a into r power n minus 1 divided by r minus 1. So a is the first term, that is 5, and r is the ratio. We had calculated the r, and n is the number of the terms. So n is equal to 6 in this case. So we can find out the value of the S of n. So S of 6, that is the sum of the first terms, 6 terms of the geometric progress, is equal to 1820. So how we got done? 5 into 3 power 6. 3 is the ratio. 3 power 6 minus 1 divided by 3 minus 1. So 3 power 6 is equal to 729. 728 minus 1 divided by 2 we will get. So 5 into 728 divided by 2, and we will be getting 1820 finally. Next sum. Find the first term of a geometric progress where r equal to 5 and s of 6 is equal to r equal to 5 and s of 6 is equal to 46,872. So in this case, what is given? The given is the ratio and the S6, and we need to find out the first term. The first term is A. So to find out the value of the A, we can use the formula of the S of n, since we have the S6 here. So formula for the S of n we know, that is A into r power n minus 1 divided by r minus 1, and here the value of the n equal to 6. Since S of 6 they gave, we will be using the value n as 6. Just by applying the S of 6 for S6, if we apply the formula A into A, value we don't know, so we are just applying A, using the A, and r is equal to 5, so 5 power 6 minus 1 divided by 5 minus 1. So this is equal to what? 46,872. So now we can equate these two. In the left hand side, we are having the A into 1506.24 divided by 4. Right hand side we will be getting 46,872. So finally we will be getting the value of the A is equal to 46,872 divided by 3,906, that is equal to 12. So the question what they asked, the first term of the geometry progress, that is A equal to 12. So if we need to calculate the next terms, you can use the geometric progress, that general pattern AR square, like this you can apply. So the first term is 12, the second term is 12 into 5, term is 12 into 5 square, that is 12 into 25, fourth term is 12 into 5 cube. So like this you can apply. Fourth question, find the sum to infinity of 9 plus 3 plus 1. So as we seen in the first slide, to calculate the sum of the series, we have two formulas. One if the series is finite, second is the series is infinite. So in this case the series is infinite, and the formula to calculate for the sum of the infinite number of series is A by 1 minus r. So to apply this formula, we need the value of A and r. So A is the first term of the series, that is 9, and r is the ratio, that is the equal to T2 by T1. So second time divided by first term, that is equal to 1 by 3. So sum S is equal to A 9 divided by 1 minus 1 by 3, and we will be getting the value, the sum of the series. Sum to infinity is equal to 27 by 2, that is equal to 13.5. Next, fifth question, find the first term of an infinite geometric progress is 8 and sum to infinity is 32 by 3. Find the common ratio. So here they gave the first term A and the S of n, and they said it is an infinite series. So we need to apply that formula for the infinite series, and we need to find the value of the first term A, the common ratio R. So the formula for the sum of the infinite series is A by 1 minus r, and we have the value of the A first term, that is 8, and the ratio we need to find out, and the value of the sum of the series is 32 by 3, that is given in the sum. So we can equate these two, and we will be getting the value of the r finally. So the value of the ratio, common ratio, is equal to 1 by 4. Next sum, find the sum to n terms of the series. To understand this type of problems, actually there is a problem already solved in the example. So the first basic thing is, in this exercise we are dealing with the geometric progress related series, but if we see this series, this is neither arithmetic nor geometric progress, so we cannot use any of these formulas. So we need to modify this series to the geometric progress. So what we can do is, we can convert means we can derive a geometric progress from this series, and then we can use the formula for the sum of the series. So to get more clarity, I will be going to that exam problem in the example, so that we'll get the clarity. Okay. So this is the example problem which I was telling about. So first, in this problem, if we see, they gave a series 5 plus 55 plus 555 plus up to n terms, and in this series, if you see, this is neither arithmetic nor a geometric series. So what we can do is we need to get a geometric progress from this series. So first step, what they have done was they taken the common 5 as the common. So the 5 taken as common, and we are just getting we are putting this 5 out of that bracket. So inside we will be having 1 plus 11 plus 111 plus up to n terms. So now what we can do is, in numerator and denominator we can multiply by 9. So denominator, the common and the 9 is coming here, and in the numerator if you multiply by 9, this series 1 plus 11 plus 111, it will become like 9 plus 99 plus 99 plus up to n terms. It will go like this. And then what we can do is we can write 9 as 10 minus 1, and 99 as 100 minus 1, and 999 as 1000 minus 1 plus up to n terms. So now this minus 1 is there in all these numbers, 10 minus 1, 100 minus 1, 1000 minus 1. This will go till n terms. So what we'll be having, we will be having n number of minus ones. So we can take that minus n as common, and we can write like this, and only the numbers 10, 100, 1000 we can write in a series. So now if you see this 10, 100, 1000 plus up to n terms, this will be a geometric series. So we can apply the sum of the geometric progress formula. The formula for the sum of the series we can apply for this series, that is from 10, 100, 1000 plus up to n terms. For only